Welcome back. In this second part of Pandas training, we'll first begin with grouping data frames. Here, we use a data set that is already existing. You can download it online from GitHub. And to begin, we first import the data set from our local directory where we saved it. So we import, and we can first check the first few rows. Cars dot head. There are several rows, the first 5 rows, and as you can see, we have several columns. We can check the shape of the data set. Remember that this is a data frame. So if we check the shape, we see that we have 32 rows and 12 columns. We can also check the basic statistics. Empty cars, describe. So this function .describe gives you some basic statistics: count, mean, standard deviation, the minimum, 25%, 50%, and 75% quartiles, and the maximum. So we can also check the mean. Empty cars mean. If we check the mean, what Pandas will do will simply go to all those columns you have and check columns with numerical data type. Then it's gonna get the mean. The next thing we can have a look at is we can get the mean using different axes. Suppose you want to get the mean for the rows alone, or you wanted to get the mean for columns alone. That's where we introduce axes. So for example, using our mean example, you can just copy and paste here, and inside the bracket you pass an argument called axis, and you say axis 0. Doing that, axis 0, it means that you're getting the mean for the columns. And if you try to do the same for axis 1, let's see what happens. You still get the mean row-wise, but does it really make sense? No. You can't say that you're getting the mean for the rows, because what is this plus this plus this? You can't get the mean for the rows because it doesn't make sense. But anyway, for demonstration purposes, if you want to get the rows, the mean for the rows, you use axis equal 1. That's for demonstration purposes, but in this example, you can't do that. So the next thing you might want to do with the data, you might want to plot a histogram. A histogram, we use the function .hist. But remember, you have to select the column that you want to draw a histogram for. So if I execute that, we see that as a histogram that has been generated for the column MPG. You can also use a different method to plot the histogram. You can also use this. This is another method where, rather than using the indexing, you can use .mpg to select the column that you want, and you use the .hist function. So if I execute that, I get the same thing. Now we go to our group by demonstration here. Now, to group, we need to specify the variable of interest, and we are going to use group by function. So you first call your data frame, then you say dot, then you use the function group by. So this is our data frame, group by function, and inside the group by function, you specify the column that you want to group by. And the group by, once you store it as grouped by cab, in this case, we need to do a certain operation like mean. So in our case, if we get the mean of a group by, then it's like we're getting mean for different categories as per the cab column. So if I execute this, we see that we have cab 1, 2, all the way to 8, and we have the different columns. So it's like you're getting the mean of MPG for cab equal to 1, equal to 2, all the way to 8. And suppose you wanted to group by more than one category. all you need to do is pass the columns that you want to group by as a list inside the group by function. And now we can check the mean for the group by the two category we just got. And actually you can have a comment just above that, which is very important, because once at some point you might want to come back to your code and you might not remember exactly what you are trying to achieve. So it's always nice to have comments. So if I execute that, you realize now you have grouped by two columns, carburetor and whether it's automatic or manual, AM, and for the different numerical columns. Next, we can compute statistics aggregated over certain groups. To do that, we'll use a Numpy function or Numpy library as follows. So you first import Numpy as np, and then we already have the grouped by the two columns. So, and then we want to aggregate, we want to get different statistics. So here we want mean and standard deviation. So we need to call numpy and then mean numpy, which is np.std, and you pass them as a list inside the agg or aggregation function. And if we run these, we get several things. So for each column, we get mean and standard deviation. And the mean is for the grouped categories for the by two columns, cab and am. Also, you might want to count the number of cars in each combination of cab and am. So to do that, we use .count function and ensure that you select the right column. So here we call our variable that you created earlier, grouped by cab and am, and then you select cab and then you say dot count, and you don't have to pass any argument inside the count function. If I run that, I get the count for each tabulator based on am. Is it automatic, which is 1, or manual, which is 0? The next thing we can do is plot the count. And to plot the count, we will use a library called matplotlib, and then we call pyplot as plt. So that's the library we are going to use, and in that library, we can use pyplot and we import it as plt. And we use the following code to plot, too much to type, so just copy and paste it there. But for your understanding, I would suggest that you type it out. If I execute this, I get this. So we have in the y-axis, we have count, and the x-axis, we have the carburetor, and we have AM. This is a stacked bar chart where we have the green part representing 1, which means that it's automatic, and the faint, it's a bit faint, represents 0. And that's how you can be able to plot the count. The next thing we might want to do with data frames and series is performing arithmetic operations between data frames. So the first thing we can do is what we call broadcasting. Suppose we had an array called R, which takes the numbers, the float values 0 to 11, and has been reshaped to a 3 by 4 array. So if I execute that, we see that it's a 3 by 4 array. And suppose we wanted to get the difference, to do some sort of operations where we want to subtract row 1 from the original array. To achieve that, we say array minus array first row. We use indexing to select the first row. If you get the subtraction, we see that what is happening here we are taking the first row minus the first row, you get 0, 0, 0. Then you take the second row, you subtract row 1, you get 4, 4, 4. You subtract the second one, the third row, you subtract the first row, you get 8, 8, 8. So each element, it's basically element-wise. The operation is happening element-wise. That's why you're getting that. We can also do the same for, we can decide to add, assuming you decide to add, we get the same. If you decide to get multiplication, you'll just get the same. It's like you're taking 0 multiplied by 0, then 1 multiplied by 1, just like that, and then put the second row multiplied by first row. So it's 0, 0 times 4, 1 times 5, just like that. We can also do the same for a data frame using broadcasting. So suppose we had a data frame that takes the same numbers and same array and convert it to data frame, and we specify that the columns is B, D, and E. What this function will do, list, this will convert this to individual string characters and pass them as the columns. Our indices for those 4 rows will be Utah, Ohio, and Texas. So if I execute this, we see that that's how our data frame looks like. Now, suppose we want to subtract a series from that data frame. We can just first define our series here. And our series is simply the first row. Remember that this is how we said we can select a row using an index. Remember we said we can use index or we can use the labels. So this one is the same, series equals to frame dot log, then you open square bracket and you pass the label. Remember, the label for the first row is Utah. So if you pass Utah there, this will simply give you the same output as when you use iloc and you pass the index. So now if you want to get to subtract the series from the data frame that we have called frame, you simply say frame minus series. If I execute that, this is what I get. So remember, it's like you're taking this minus itself and then row 2 minus this one. So it's row wise. So it's 3 minus 0, 4 minus 1, 5 minus, so you get 3, 3, 3, and the same happens for the other rows. And suppose now you wanted to broadcast down the columns. So to do that, we can define a series that now selects a column instead. So as you can see, we specify our column. So our column will take D for all of this. And now suppose now you wanted to subtract that column from the frame. So here we use the sub function and we pass our series as an argument and we specify that we're interested to do that row wise. So if I execute this is what we get. We get -1, 0, and 1 for all. Because it's 0 minus 1, 3 minus 4, 6 minus 7, 9 minus 10. You realize you get the first column in the results will be -1. This will be 0 because you are subtracting D from itself, and this one will become 1 for all the entries. A closer look at indexing, we can start with series. We can have a title there, convert it to markdown. So here we have a series that takes 3 numbers, 0 to 3, and the indices is A, B, C. And suppose we want to change the index 1, this one, to D. Let's see what happens. We get an error. This is because index objects are immutable, meaning that they cannot be modified by user. What that means is that once you've defined the index or the indices, you can't change them. So that's why you are getting an error. So what if now you wanted to change it? Suppose you did something wrong and you said this is X instead of C and you wanted to change it. Then we use something we call reindexing. Reindexing, we can use an example. Suppose we had a series called object that takes 5 values and we have our desired indices. So if I do that, that's our series. And we wanted to change these indices to a different now letters. To do that, we can simply use reindex function and you pass our new indices as arguments. So if I execute that, I see that the indices for object have been changed. And given that I've passed more than enough indices, the last one will be assigned NaN. It's not a number. So suppose now we wanted to reindex and initialize anything that is missing. Here we'll use reindex function, pass the indices, and we specify the field value to be 0. We can go ahead and run this and see what we get. So in this case, as you can see, the value NaN has been replaced with 0. Again, we might want to reindex and initialize missing values with the forward fill or the backward fill method. So in this case, for instance, we might have an object 3, which is a series with a list of 3 string characters, blue, purple, and yellow, with index 0, 2, and 4. We can go ahead and run that. Object 3, we see that it has 3 values. The series has 3 string characters, blue, purple, and yellow, and index is 0, 2, and 4. Suppose now we wanted to reindex such that we have index 0 all the way to 5, and anything that is missing be replaced with method forward fill. So in this case, we use this method as follows. So here we reindex with 0 to 5 with method called ffill, which means that since we have 0, that is blue, but since we don't have 1, it's gonna be prefilled using this method. So if I execute this, I see that we had our 0 to be blue, and given that 1 was missing, then the value for the previous index will be carried forward. So the missing value has been replaced with the previous value, and we see we didn't have 3, so it's replaced with purple. We didn't have 5, so it has been replaced with yellow. You can as well decide to use a different method. Suppose we decide to use, for the same one, I can rerun this object 3 to get the series. So if I decide to use a different method, backfill, and rerun this, let's see what we get here. So here, you see that the missing values are being filled with the next values. So in this case, since 1 was missing, index 1 was missing a value, then has been replaced with purple. I hope that is clear. So we can have a closer look at indexing. So a closer look at indexing, and to look at this, we can use a data frame that takes the values from 0 to 8 and reshape that into an array, and the index is A, C, and D, and the columns are named Ohio, and that has been converted to a data frame. So I can go ahead and run this and print it out. So now, suppose we wanted to reindex such that we have A, B, C, D. Remember, we don't have a B. So if we decide to reindex like this, I can go ahead and execute that. B, since it was missing, it's NaN for the whole row. And that's a way of reindexing the rows. you have to specify index. But if you wanted to reindex the columns, then we can first declare some states this way. And then after declaring some states, which is a list, and as you can see, we have Ohio, Texas, and California in our frame. But the ones that we have declared here, we have Texas, Utah, and California. And we can reindex. To reindex the frame, we simply say frame.reindex columns equal state. Let's see what we get after we execute this. We see that we have now replaced the columns Texas, Utah, and California. So we have our Texas there, which takes our frame. You see, this is the frame. We have our Texas because we have the Texas there in our states, list of states. We don't have Utah in our frame. So meaning that Utah will be NaN, and then we have California, which had the values in that column 2, 5, and 8. So we have those. And just like that, Utah has been added with the values NaN. So, and that's how to reindex a column. So the next thing you are going to look at is how to perform series indexing. For series indexing, you should realize that series indexing in Pandas works the same way as Numpy indexing. Remember, a data frame or a series is simply an array, and Pandas is built on top of Numpy, so they work in a similar manner. So you can have a comment there. And the only difference is we only use index values in place of just integers. Remember, for Numpy arrays, they don't accommodate index values. We just use integers. So, but in Pandas, we can use the values or the labels. So suppose now we had an object, a series that has four values, and these are the indexes A, B, C, and D, and we wanted to get the second object in that series. So we can go ahead and just print that out. Now suppose that we wanted to get the second object. For example, we want to get this one. So we see that it has the index B. That is B is the index label, but in reality, the index is 1. So we can get this value in two ways through indexing. First is using 1 in the square bracket, or we can use the label B as follows. If you go ahead and execute these, you realize you get the same thing, because Pandas series allows us to do indexing using the integer or the index labels. Also, we can do slicing, and slicing we can use index labels to specify the start and the end. We can do it as follows. So we can specify the start index and the end index using the labels. So if I execute that, I see that I'm getting B, C. Remember, when we use the labels, both are included. But if we decide to use slicing using the index values, then it's going to be different. For example, if I go ahead and do the same and use object, then we know that B is index 1 all the way. We know that C is index. So if we do this, you realize this is what we get. We get 1. Mark the difference. If we use the index labels, then both are included. But if we use the index values, only the start index is included and the end index is not included. So in this case, 2 is not included. Hopefully it's clear. But if you have any question, please post them in the comment section. Now we can go ahead and look at data frame indexing and see how we can achieve that. So suppose we had a data frame and we wanted to retrieve more than one column, because the data frame will allow you to index to retrieve more than one column. So suppose we had that data frame with 16 values starting from 0 to 15, and is forming a data frame, 4 rows and 4 columns. And the index are just like this, with Ohio, Colorado, Utah, and New York. And the columns are 1, 2, 3, and 4. So we can go ahead and print this out. So we see that's our data frame. If you wanted to retrieve a column, all you need to do is just do the normal indexing and use the column label just the way we did for indexing. So here we retrieve one column called 2, just this way. We can go ahead and run that. We get just the second column. We can get the fourth one 4, just like that. So we see this is what we get. If we wanted to retrieve more than one column, then it means that we need to pass a list of columns that we want to retrieve. If we wanted to retrieve 2 and 4, so you see we have retrieved the 2 columns. And we can also do slicing using the column names by simply writing the first column all the way to column called Utah, and this is colon in between to enable you do the slicing. So here we've actually been able to get the 2 rows. We're getting 2 rows. So here we're using slicing with the index labels. And just like that, we've been able to get all the columns for the two rows with the index Colorado and Utah. Also, we might be able to do slicing with row numbers. And to do that, we simply use this. You can say data. The start index is not provided, but the end index is provided. But remember, when indexing and you're using the numbers, then you won't include, when slicing, it won't include the end index, which means that this, which happens to be row 3, will not be included. So it's gonna get all the rows up to the row with index 1. So that's why you're getting two rows, which happens to be rows with number 0 and 1. 2 is not included. That's why we only get 2. We can also do filtering, and to do filtering, we only use something that's gonna give us either true or false. For example, here we want to get all the rows or the data, all the rows for which column 3, the column named 3, is greater than 5. So in this case, we see that the only row that violates that rule is the first one. So meaning that when we execute, we are supposed to get these 3 rows. Let's go and confirm if that is the case. So execute, I get the 3 rows because the first row, the value for the third column was less than 5. So that's how we actually do filtering. We can play with this. We can say maybe less than 5 and execute. We see we get 1 row for which column named 3 is less than 5. And we can also use a boolean statement to generate either true or false. For example, we might want to check, we might want to convert data, the whole data set or the data frame, to be either true or false if the value is less than, any of those values are less than 5. And to do that, we use this statement. So it's data, and then you use the less than operator and 5. So if I execute this, you get a data frame with either true or false. So if you decide to incorporate or maybe to change everything to 0, we can simply do this. You can actually replace everything that is less than 5 with 0. And to execute that, so anything that was true has been replaced with 0 because that's the condition we set. So what we are doing here, we are taking in our data frame called data, anything that is less than 5 is being replaced with 0. And that's exactly what happens there. The next thing we might want to do is select a bunch of rows and columns. For example, if we wanted to use something called loc and iloc with our data frames, we convert that to markdown. So I want us to do this and see if we want to use the location loc data.loc. This one is simply gonna select some specific rows based on their labels. For example, we might get Colorado for columns 2 and 3. So we expect to get 5 and 6. Let's execute that and see. You get 5, 6. Another example we can use is this one. Suppose now you wanted to get column 2 and 3 for 2 states, Colorado and Utah. All we need to do is use loc, and then we pass 2 sets of list for the specifying the rows that you want and the columns that you want. So if we execute these, we get column 2 and 3 and row named Colorado and Utah. And then we might as well decide, instead of using the labels, we can decide to use iloc or the actual values. So for this one, this means that I want to select row. This is row 3. If I execute this, I get is a column, all the columns, but for row 3. Row 3, because it's this 0, 1, and 2. So this is what I'm getting from this example. And suppose now you wanted to get all the rows before Utah and return only column 2. This is what we use. You realize that before comma, that's why we specify our rows, which rows we want to select, and after the comma, we specify the columns. So here, we want to get anything all the way up to the row called Utah. So if we execute this, we see that we are getting row 1, row 0, 1, and 2, and we are getting the values from column 2. I hope that is clear. Thank you for watching. See you in the next part of this Panda tutorial.